Hola, my name is Alejandra and I'm a cloud developer advocate at AWS. I'm also pretty in love with robots, which you'll soon find out by the end of this presentation. Before we begin, I have a question. Do you like history? Then get ready, because we're about to time travel to the 19th century. Are you ready? All right. So, you can see here that this is a postcard. This postcard is actually from a part of a series of futuristic pictures that were issued in France in the 19th century. These images depicted how they imagined the world could be in a faraway world of 2000. Look at that, right there. Now, this particular postcard shows a visionary future of machine-automated chores, but note how the concept of an autonomous machine hasn't been thought of yet. No doubt, many people who saw these invention ideas back then probably laughed and said that these pictures, these ideas, were much too far-fetched. All right, are you ready to time travel back to 2020? What is that? Have you ever heard of a Roomba? Roombas are autonomous robotic vacuum cleaners sold by iRobot. They were developed originally in September of 2002. Wow. It looks like the artist of this postcard was only off by 2 years. That's crazy, isn't it? Okay, so today robots definitely can accomplish a lot more than they could 200 years ago. And it's really interesting, isn't it? And I have to say that for a long time I've had a couple of burning questions in my mind. In fact, you could say that those questions are what inspired this talk. So you see, sometimes I wonder, what if robots are just what our healthcare system needs to improve patient care? Or maybe they could also help keep workers safer by doing dangerous activities such as disinfecting hospital wings themselves instead of putting something like a human to do that dangerous work. Another thing that I wonder is, what if robots could be used to ensure that the elderly can feel safer and closer to their loved ones? Of course, this in itself raises a lot of other questions. Robots are already in healthcare. They're already helping doctors and nurses, and they're definitely not replacing doctors or nurses. But we are seeing a huge provider and doctor burnt out, and this is happening at accelerated rates. So what can we do to make this better? What can we do so that this doesn't get worse when there's a pandemic or a crisis? Anything that can help a doctor or a nurse in an assistant capacity makes it easier for them. So anything that allows doctors and nurses to interact on a more personal and safer level with their patients is going to be a huge win, right? Okay, now don't worry. We're going to go ahead and get ready for the next section of the talk. Let's get straight off into our agenda and see what we're covering today. So, I want to show you some customer examples of how AWS is already working and giving back to the open source communities within the robotics space. I also want to give you guys a tiny little demo, a taste, if you will, of the AWS tools that we have in the RoboMaker console that allows us to test our robotic applications and test simulations. So I'm going to show you what some of those simulation tools feel like. We're also going to dive into some examples that showcase the current state of robotics and AI in healthcare today. And we're going to talk a little bit about how robots are being used in society today to improve patient care, to help doctors and providers during a crisis, and many, many more interesting examples. But let's start with the very first part of ROS. Before we get into anything else, I need to tell you guys about ROS. So what is ROS? ROS is an open source middleware based on an anonymously published subscribe mechanism. This mechanism allows messages to pass between these ROS processes. These are what we call nodes. In this simple example, you can see that I pretended to have a topic called Canela, which is actually the name of my dog. And the message type is a string. And we can see that we have one publisher node and there are two nodes that are subscribed to this topic. All right, now why am I telling you about ROS? Why does this matter? And what does this have to do with robots in healthcare? Don't worry, we're getting there. Let me tell you a little bit about how ROS came to be, and then you'll see how it all fits in. So, a little over 10 years ago, a group of students at Stanford University were doing research on robotics for their PhDs. They made the observation that even as researchers, they were being slowed and they had to build everything from the ground up. So they started to ask the question, hey, what if we could write software to get our project up and running? What if we contributed to that open source so that people who come behind us can take advantage of all of this? And this led to something that is called Willow Garage. Now you know why I have a Willow Garage logo right there, don't you? Yes, see, Willow Garage was the group of people that for years have continued to contribute to writing open source software for robotics. And this software, this open source software for robotics that this group developed is called ROS. Ah, see, now it all makes a lot more sense. So what is ROS? Let's get into a little bit more details. As we already mentioned in the previous slide, it is a publish and subscribe framework. We already learned that it's open source because I just told you the story of Willow Garage and how ROS came to be. It has a huge developer community, and here's the interesting part. ROS is being actively used more and more for commercial applications versus only academia and research. And we'll get into a little bit more of this in just a moment. Now, that said, ROS is actually also having to move to another version of ROS 2. And AWS is trying to accelerate this adoption of ROS 2. Why? Well, as you can see, ROS 2 brings the advent of security. It was designed specifically with security and DDoS standards in mind. This is the difference from ROS 1, which was really only being used for non-commercial applications, for academia. And as you can imagine, it isn't until you start thinking about commercial applications that you realize, oh, you know what? We really do need security. We cannot ship this to prod unless our application is secure, right? Okay. And it's awesome to see that moving forward in ROS 2, we're going to have a lot more capabilities. Okay, so at the heart of any ROS 2 system is definitely going to be the ROS Graph, okay? The ROS Graph refers to the network of all these nodes in the system and the connections by which they're able to communicate with each other. I think that it would be really good if we had a quick overview of some of those ROS Graph concepts. So let's go ahead and get started on those. So we're going to learn about nodes, messages, topics, and discovery. Ready? All right. So what is a topic? A topic is an entity that uses ROS to communicate with other nodes. Messages is a ROS data type used when subscribing or publishing to a topic. A topic. Okay. So remember, nodes can publish messages to a topic, but they can also subscribe to a topic to receive messages. And lastly, discovery, the automatic process through which nodes determine how to talk to each other. So, what can ROS do? Well, there's all kinds of packages, guys. It's insane. ROS is an incredibly rich ecosystem. And I have to say that in terms of commercial robots at AWS, we do begin to think that ROS could be the Linux for robotics. And we're going to get into a little bit of this in just 1 second more. Don't you worry. The first thing we're going to look about here is, we mentioned here that there's packages for simulation in 2D and 3D. So the next section is going to be about simulation. That's right. Did you know that when you're building robotic applications, it doesn't make sense to immediately ship your code to a physical hardware robot? Absolutely not, because you still need to test your code first. So what actually you want to do is you want to ship your code to a simulation, test drive it, see how your code is working in the simulation, and then if your code is working as expected, then it would make sense to consider to deploy your code to your actual physical hardware robot. But the truth is that simulation saves us many hours and a lot of development hours for people that have to deal with all these tests. So let's learn a little bit more about that, okay? So here we see that we're going to talk about 3 main simulation validation tools, and this is going to be Gazebo with an ignition plugin, RViz, and RQT. Gazebo is a 3D dynamic simulator that allows you to simulate populations of robots in an indoor and complex environment. RViz, which stands for ROS visualization, is also a 3D visualizer, but this, instead of being a simulator, instead it displays sensor data and state information from ROS. And then lastly, RQT is an amazing software framework of ROS that allows you to implement the various GUI, graphical user interface tools, in the form of plugins. For example, you could build a quick and dirty control panel and a status window for your robot. Don't worry, we're definitely going to show you this a little bit more in detail later on in the demo that I told you about. Okay, so this is actually a scene from an internal workshop that we created for you to become better familiar with AWS RoboMaker and using ROS. I haven't explained to you about RoboMaker yet. We'll get into that in just one second. But for now, I want you to see that some of the worlds that we create here for you to simulate and do your testing and simulation with your robots are just really, really cool. In this one, for example, we learned to simulate the NASA JPL open source rover. It's so much fun. You guys want to check it out later on for sure. Okay, so let's talk a little bit about the engine powering all of this behind the scenes, right? So we mentioned Ignition being a plugin for Gazebo, right? So this allows users to have access to high fidelity physics, rendering, and sensor models. I mean, you can see that the graphics here are pretty amazing. And then let's talk a little bit about the physics behind Gazebo and the work behind that. So Dart is actually the default physics engine used in Ignition, the plugin that we're talking about. And this allows you to provide a level of accuracy when you're suppressing that definitely surpass many game engines. It's really, really cool, and you can see that you get the option to choose whatever engine you prefer at runtime. Now, if you want to iterate fast on your new physical designs in a realistic environment, you're going to need a really high fidelity sensor streams from your robot or from your simulation environment, right? So when it comes to things like depth cameras, LiDAR, monocular cameras, all of these types of sensors are available, and even more sensors along the way. And then each sensor is going to be able to optionally utilize things such as a noise model, for example, to then inject custom noise properties into your simulation. Isn't that crazy? So we're not just talking about visual elements, we're also talking about audio elements, audio in the simulation that you're testing for your robot code. Oh my God, that's so cool. All right, and then lastly, we mentioned that this is an extension, right? It's a C++ plugin. Most of the time, you're going to see that the people are using things such as C++ and Python when it comes to robotics development. And in this case, users and developers have multiple points of entry to simulation, including a GUI, plugins, and asynchronous message passing and services. Gazebo is really, really cool. I cannot emphasize enough how much I love playing around with this tool. All right, now we also need to understand a little bit more about fleet management, and we're going to tell you what that is in just 1 second. So let's get talking about AWS RoboMaker. I mentioned that to you a second ago. I mentioned to you ROS, and then I told you that I would tell you about RoboMaker. What is AWS RoboMaker? Well, it's a service that makes it easy for a robotic developer, or actually even a new developer to robotics, to develop, test, and deploy their robotic applications. All right, now there's a couple of really cool capabilities that I want to tell you about. RoboMaker offers 4 independent yet fully integrated capabilities. We have a one-click IDE installed, cloud extensions which are available in our main RoboMaker page, simulation that we've just talked about and we'll see in a little bit in a small demo, and of course fleet management that I told you about. What is a fleet? A fleet is a group of robots, and currently AWS RoboMaker is offering over-the-air deployment with AWS IoT Greengrass. So you can use your deployment settings in your AWS RoboMaker console to tell us how many robots to deploy your code to concurrently and at which level you wish to fail the deployment. In this example, you can see that we have chosen a failure threshold of 15%. What does that mean? Well, I'm going to deploy my code to only, say, a percentage of my robots. And if more than 50% of them aren't working and my code fails, that's it. I don't want to finish deploying the code to all of my other robots that I have in my fleet. I'm going to go back, do some more testing, and see what went wrong. All right, I know that this is what you've all been waiting for, the simulation demo. You want to know what it feels like, and I completely understand. All right, let's go ahead and get this demo started. So here at this point, you can see that we have a running simulation. I did this beforehand because it takes a while to get these runnings. So what does this mean? With the simulation, we have your robot code, some simulation code, and resources bundled together, and that is how we can have Gazebo running in the background in the cloud like we told you. First, let's start with Gazebo, the 3D dynamic simulator that allows us to simulate populations of robots. In this case, you can see that we are opening a sample world of a bookstore. This was actually built by the AWS Robot Maker team. They've made it publicly available, and you could check it out on GitHub as well if you wanted. Super easy to use. Another thing I want you to notice is that we are using Kinesis Video to stream the camera image to Amazon Recognition. And you can see that our robot moves around and we have the option to zoom in and out. Let's head on over to RQT. So, RQT, we told you, is a software framework of ROS that allows you to implement different GUI tools. In this case, we're going to pretend to open a plugin for image view. This is going to allow us to see the robot's perspective from the camera feed. This becomes particularly useful for visualizing data that's coming in. In this case, we mentioned that we opened a sample bookstore world. So what we're looking at here is the perspective, the view of the robot from its camera. All right, let's head over to RViz, ROS Visualization, the 3D visualizer that allows us to display sensor data and state information from ROS. RViz shows us different visualizations that help us understand how the robot is viewing its world. Now, let me give you an example of this. First of all, you can see that the background for this particular one is definitely different. It's very hard to see a dark gray robot against a black background, so I switched it up to gray, as you can see here. There we go. Now we can see our robot moving around. Same to the other simulator Gazebo that we opened. You're able to zoom in and out. You can move around in your world. You can move your camera location. You can do pretty much anything. And you can also add things to give you an idea of how the robot is viewing its world. So in our case, we're going to add a laser. This laser is going to allow us to see the views of the laser sensor from the robot. You see I made sure to update the topic to scan. And then I'm noticing that it's kind of hard to see the lasers because of the small size. So I'm switching from 0.1 to 0.5. Yes, what a difference that makes. Isn't that cool? Okay, now we got an idea of what it feels like to play with Gazebo, RQT, RViz. Let's head on over to the terminal. Yes, we can actually open a sample terminal from here from the AWS Robot Maker console. And what I want to do here is I want to check out a list of sample ROS topics that are here. So let me go ahead and check that out, verbose method, because what I want to show you here with the verbose method is you're able to see not just more information about individual topics, but you're able to see which are the published topics right there at the top, as you can see. It'll show you how many publishers it has for each topic. And then if we search through this immense haze of many, many topics, as you can see, eventually we should also be able to run into the subscribe topics. Oh, there we go. Subscribe topics, there we go. And each individual topic, you can see how many subscribers it has. What if I wanted to actually echo one of those topics and see what that topic is listening to or what's going on with it? I'm going to check out this common topic that pretty much any robotic application would have, which is CMD_vel, which stands for command velocity. And we were able to see that the terminal showed us the sample parameters and velocity of our robot. All right, so that was a pretty quick and dirty demo, but now you get an idea of what it feels like to be able to test and simulate your robot code. It feels a lot like a video game, doesn't it? Okay, so I also wanted to share with you guys some amazing customer stories that really fit in. I'd like to tell you about my favorite one so far, which is Leah, the autonomous robotic walker. What can Leah do? Leah is autonomous, as I just said, but what does that mean? It means that I can actually call Leah to me. I can tell Leah to go charge itself. I can tell her to go anywhere in my house, and Leah will build a map of my environment because it can navigate just like any other robot that you've seen. Leah is also immensely interactive. The handlebars can detect your intention when you lean on it, and it starts moving with you. You know, you can even dance with this thing. There's a dance and exercise mode on it, and it safety locks so you don't trip. Not to mention it has over 70 sensors. It is insane. And the cool thing about Leah was that they were able to use AWS RoboMaker Cloud extensions with ROS to enhance Leah to have voice interaction capabilities. Now let me show you the other one, which is iRobot. Now the cool thing about this customer example is that iRobot, with the use of AWS RoboMaker, was able to go from executing 100 to 5,000 test scenarios a month. That's a huge change. If you're able to run almost 20 times the number of tests that you were doing before, simply because you're using simulation versus trying to deploy all your code to an actual hardware piece, this alone should show you how much the panorama changes when you have simulation available in robotics. And I think this absolutely applies to our current topic of the day, which is robotics and AI in healthcare, because if we want to improve the presence of robotics and AI in healthcare, we need to start getting more comfortable with testing our code. And the best way to do that is to become familiar with simulation tools, because the more we simulate complex environments within hospitals and different healthcare environments. It could be, for example, if it's an elderly patient, it could be a nursing home, right? There's all these different environments that we have yet to really map out and test in a simulator. And if we want robotics and AI to bring healthcare to the next level, we need to get going on that. Okay, what kind of robots are already in healthcare? I know that you know that some of them are already going, but let's talk about this. All right, so we know that doctors are definitely more than enough competent to take care of people. We already talked about how we don't want to replace human doctors or nurses. That is not the point. We just want to talk about how surgical robots can really make such a difference. Robots allow surgeons to perform precision surgery, which means smaller incisions. But this isn't all. Other benefits could be less blood, less scarring, better access to an area being operated on, reduced risk infection, and a faster return to your life. This is a huge deal. And then there's telepresence robots. Not so used yet in healthcare today. They're remote controlled, and they usually use a tablet to provide video and audio capabilities. You see these a lot of things like in tour guides and factory inspections, definitely healthcare consultants as well. These have gone back and forth. We're not really sure how useful they are yet, but hey, we got to keep testing these things. And then finally, the question of the day, are robots currently or in the future, can they help us during a healthcare crisis? And I'm just going to say it. Robots are great for cleaning hospital wings previously occupied by sick patients, because guess what? Robots can't get sick. So why should we rely on humans to disinfect a hospital if instead we could have a robot, for example? Hey, and what about robots that can help the elderly? Like we mentioned before Leah, but what about this one over here, James? James is an awesome robot that navigates rooms and connects video calls for these patients via Facebook Messenger. It's a perfect solution for helping elderly who are longing for in-person visits and who sometimes face extreme isolation or loneliness when they are within their nursing homes. And what about healthcare crises or pandemics? Well, robots are definitely a safer way for doctors to perform initial screenings of patients that we are concerned may be sick. In this case, we're seeing an awesome thing going on in this India hospital. They're using this camera, a thermal camera equipped robot, to take the patient's temperature without needing to touch them. The tablet on the robot's chest allows the doctors to video chat with the patient without putting their own health at risk. Crazy, isn't it? And then check out this other one over here. So all of these robots are being shipped to this hospital in China, and hundreds of these ultraviolet disinfecting robots are, in a way, really making changes because they're helping discover new ways of disinfecting patient rooms and operating theaters in hospitals. This is insane. These robots are able to disinfect pretty much anything that you point at them. So as you can see, I mean, there is just so many ways in which robots can really help healthcare today, improve patient care. So I know what you're thinking. Hey, does this mean the robots just solve everything? That's it, right? We just need a robot. Let's just put a couple of robots or 1 million robots in every single hospital. That'll solve everything, right? Unfortunately, it's not so easy because you have to think about space. Robots take up a lot of space. You know, they're not these tiny little things. Humans also take up a lot of space. So let's talk about the complex logistical planning that goes behind doing something like this. Hospitals are really crowded. You know, there's people being rolled back and forth everywhere, doctors, patients. There's not really enough space right now in a hallway for us to just think about dropping a whole bunch of robots to disinfect things and make things better in a hospital. And the other thing is that at least today, people are still better at avoiding robots than robots are at avoiding people. So how much can we really risk just putting in a whole bunch of robots in a complex and environment like a hospital and hoping that the robot won't make a mistake and bump into the wrong thing or the wrong sick patient? You could see easily how this could really get out of hand. So in closing, I do want you to think about one more thing though, and that is, the truth is, there are definitely a lot of setbacks that robotics has to solve before robots with AI could really improve and change healthcare like we were dreaming about a second ago. And yes, that's true. Robots today aren't ready to disinfect hospital wings and just save the world during a pandemic. Not quite yet. But what about 200 years from now? What about then? What could happen? Who's to say that what we think impossible today isn't something that we could achieve tomorrow? Okay, I hope you really enjoyed this talk. If you have any questions, if you just want to talk, send me a message, an email, a DM. I'm always here ready for customers. I love talking to you. And I hope that you enjoyed this session. Thank you so much for being here, and I hope you have a very nice day. Bye.